Okay, this lesson is going to help you work through chapter 3, section 3, lesson 1. All right, so what if an equation has a product? So solving equations with multiplication and absolute value. So now we're going to be going into not just rewriting by using some of the different properties, but now actually doing some solving. All right, so it says now that you know how to multiply algebraic expressions, you can solve equations that involve multiplication. You will also solve equations that have absolute value in it. Okay, so this first part is just review. So, if you printed out this paper, you can do the work on here. If not, you can just do it in your notebook. But I want you to start out by seeing if you just multiply 6x minus 11 times 2x plus 5. All right, did you think to maybe make a generic rectangle? Or if not, you might have just done, foil to make sure you get the parts. The generic rectangle is nice because it does help you, um, you know, um, deal with the subtraction sign pretty well. So 2x times 6x should have been 12x squared. If I take 6x times 5, that should have been 30x. 2x times negative 11 is negative 22x. And then negative 11 times 5 is negative 55. All right, so I can write this as 12x squared. I'm going to combine the 30 and the minus 22x to be 8x, and then minus 55. All right, can you go ahead and try letter B? Okay, so did you just use either just the distributed property like that, or did you use the generic rectangle? So for a visual, I've got 2x squared times 15 x squared minus 3t. So I'm going to multiply these together, thinking of my exponent rule. So negative 2 times 15 is negative 30. And then if I've got x squared times x squared, that's going to be x to the fourth, same basis. When I'm multiplying, I'm going to add the exponents. Okay, now I've got negative 2 times negative 3. That's going to give me 6. Okay, these are different bases, so I'm just going to leave it as x squared and then t. So I've got negative 30 x to the fourth plus 6x squared t. Okay, let's look at C. Okay, and again, if you want to make a generic rectangle, you could. So I have 6 minus y, y, 2. 6 times y is 6y. 6 times 2 is 12. Y times negative y squared. And negative y times 2 is negative 2y. All right, so negative y squared. I'm going to combine these two things together to give me plus 4y and then plus 12. Okay. All right, so then we've got 16 times 3 minus m. You could just use the distributive property, or you could draw a generic rectangle if you're liking those. Okay, so 3 times 16 is 48. And then 16 times negative m is negative 16m squared. Okay, so I'm going to write this as 48 minus 16m squared. Okay. All right, next, let's see if we can solve these equations. It does say use the distributive property or draw generic rectangles to help you rewrite the products. Okay, be sure to record your steps as you're going. Okay, so I want you to go ahead and try and solve A. All right, did you start with a distributive property? Okay, so I've got 2y minus 4 is equal to negative 6. I'm going to try and isolate the y. I'm going to add 4 to both sides. So 2y is equal to negative 2. When I divide by 2, I get y is equal to negative 1. Okay, let's try B. I'm going to go ahead. I'm going to use a generic rectangle to make sure I get the products for this one. So I'm going to do x minus 1, 5x, and 6. So 5x squared, 6x, minus 5x, minus 6. So I've got 5x squared plus 43 is equal to 5x squared. 6x minus 5x is just plus an x minus 6. Okay, I'm going to subtract 5x from both sides. or sorry, 5x squared from both sides. So I got 43 is equal to x minus 6. Okay, I'm going to add 6 to both sides. So let's say 49 is equal to x. All right, so a few more of those. Okay, so generic rectangle might be helpful for this one. Okay, to make sure you get the products. But basically you're going to get x squared plus 3x plus 4x, so plus 7x plus 12. Over here I'm going to get x squared plus 1x plus 2x, that makes plus 3x plus 2. All right, so I'm going to subtract x squared from both sides. So I get 7x plus 12 is equal to 3x plus 2. I'm going to subtract 3x from both sides. So 4x plus 12 is equal to 2. I'm going to subtract 12 from both sides. So 4x is equal to negative 10. Now my last step, I'm going to divide by 4 to isolate my x. X is equal to negative 2.5. Okay, so let's try this one. Okay, distributive property. So 2x plus 2 plus 3 is equal to 3x minus 3. I think I'm going to simplify this first. So I get 2x plus 5 is equal to 3x minus 3. I'm going to subtract 2x from both sides. So I get 5 is equal to negative 3. Oops, 5 is equal to x minus 3. Sorry about that. I'm going to add 3 to both sides. So I should have gotten x is equal to 8. Okay, so that's how we could use the distributor property, which allows us to multiply a monomial times a binomial, or actually so like a single term times a sum, or to multiply two terms together. We talked about those being two binomials, and then we could try and still isolate our x. Okay. All right, so now we're going to look at some absolute value equations. So it says find as many solutions to the following equations as you can. All right, so what number has an absolute value of 5? Did you think that 5 and negative 5, that there are actually two solutions there? How about for this one? Did you think 133 and negative 133? Okay, how about for this one? What number has a distance from 0 of negative 2? There's no number, so there's no solution. Okay, and then how about this number? What number has a distance from 0 that's 10, and what would x have to be? Okay, did you think that this would have to either equal 10, or this piece would either have to equal negative 10? Okay, what x value would actually give 10 as a result in here? X would have to equal 17, or what x value would give a negative 10 in there? Okay, so x would have to equal negative 3. Okay, so one thing that you're noticing about absolute value equations is that often there's two answers that will work. Okay, let's try and figure out this one. We've got the absolute value of 3x minus 5 is equal to 16. What do you think x is? Did you think that 3x minus 5 would either equal 16? Okay, in that case, what would x have to be? X would have to be 7. Or 3x minus 5 would have to equal negative 16. So that inside piece would either have to be 16 or negative 16. So 3x is equal to negative 11. I can just keep this as negative 11 thirds. Okay, let's try one more of these. So how do we solve that? Did you realize that this inside piece, 7 minus 8x, would either have to equal 1? So x would equal 3/4. Or this inside piece would have to equal -1. Okay, so x would either have to be 1 or x would have to be 3/4. Okay, so there's two answers for that. Okay, a little different than most of the linear equations that we've been doing where there's just one solution. Okay, so hopefully you have some skills on how to use the distributive property to solve some equations and also how to solve an absolute value equation.